this is the fun stuff to put on video.
Are these what would be called fold mountains?
These?
Fold ridges, yeah.
No. They're basically interbedded sand and claystone. So you can see they dip down that way. So each successive bed that we drive across, we're going up section as we go here. You can see the tilt right there on the hill there. So
is that kind of the ripple effect from the constructive of the abductive?
No, well, it's yeah, I guess in a sense it's what's called a molasse deposit. It's basically coarse grain or medium to coarse grain sediment shed from a rising mountain front and shed in a continental environment. So these are like broad braided river plain basically. So you end up with sheets of sand, and then you'd get a period where the slope changed due to tectonics, and there you get the interbedded claystones, which are representative of like swampy deposits. But these sands form sheets, very broad sheets, like we're driving along a claystone interbed right now, which is between this layer right to the right of the road. Between it and that sandstone layer on the hill, there's probably 10 meters of clay here. And it's all tilted 25 degrees or so. So this section that we're...
It's more the claystone interbed is more prone to erosion than the surrounding...
Is more what?
Prone to erosion than the surrounding strata? Or?
Well, it's more prone to, in the term is it's recessive. So it gets removed, leaving these notches at the. But as you can see, the beds are tilted quite steeply to the right, and that's the result of a secondary tectonic event that the Pulcana region it represents. That there was a large fold formed right at the margins of all the tectonism that lead up to the high Zagros Mountain. Beyond the next ridge over there is the Mesopotamian plain. So it's basically flat, undisturbed rocks that way. And this is sort of the last gasp.
Yeah.
So this was folded, but then as it was folded, there's an intervening salt layer that caused the folding to come undone from the folds underneath. So this whole thing is riding on a salt layer, and it bunched up and then thrust up along the salt layer at the edge of the what I call Minefield Ridge back that way. The first sort of prominent relief we see when we come towards the rig from the blacktop. That's a thrust fault. It's basically been pushed up on top, but because it came unglued on the salt. So here you can see the tilt. There's a claystone layer right there. The tilt is quite substantial. And as we go northeast from here, the tilt gets even more so. Like it probably gets up to 50 to 60 degrees even. But as we go that way, the tilt decreases until we reach the axis of the anticline, and that's basically the target that we're drilling in at depth. GPS and mark this. Oh well. So we're just a little bit east of Pulcana D then, just up here. It's right up on the hill. Okay.
Where is the constructive boundary? Where is the plate moving from?
The plate is the Red Sea is the opening rift. So the Red Sea, the Gulf of Aden, and the East African Rift System all meet in Djibouti. Yeah, like it's called the Afar region. It's like where the constriction is at the south end of the Red Sea is actually a bit of ocean crust that never has been thermally uplifted.
Yeah.
So there's actually dry land with the basalt underpinnings in Djibouti. So that part is the north end of the East African Rift System, the west end of the Gulf of Aden, and the south end of the Red Sea. They all meet together in what's called a triple junction.
Near the Sinai Peninsula, is that?
It's what?
Is that near the Sinai Peninsula?
Well, no, the Sinai Peninsula is there's the Gulf of Suez on one side and the Gulf of Aqaba on the other. And the Gulf of Aqaba is what's called the Red Sea Rift Fault. So the Red Sea Rift and the Sea of Galilee and the Jordan River and the Gulf of Aqaba are all related tectonically. They're a transform fault that moved. The east side of the fault moved north, and the west side of the fault is stationary or moving south. And the Arabian Plate boundary runs up the center of the Red Sea, then up the Gulf of Aqaba, through the Dead Sea Rift, through the Sea of Galilee, and then becomes diffuse in what are called the Taurus Mountains in the south of Turkey.
Yeah.
And then those are formed by the upward sort of a rotational northeastward movement of the plate towards the soft underbelly of Turkey. So here we are, the little oasis. So yeah, so the motion is not directly a direct collision either. There's a bit of rotation involved, which means a bit of smearing. It's not a straight-on collision. It's kind of a.
Is that like is that the Coriolis effect, or is that?
A Coriolis effect, I suppose, might enter into it in some small way, but mostly it's due to the position of the Red Sea Rift. You know, the Red Sea is the spreading center, where the Arabian Plate is being separated from the African Plate. So this upper Fars sandstone we're here is, can't remember the age in millions of years, but it's, you know, in the 10 to 20 million year old phase, somewhere in there. And here we are.
This is the story.
Party Central. Cool.
I even got a dragon.
Very cool.